Hello guys, my name is Bhupesh Vasu and I will be talking about the decoder circuit. Last time when we were talking about the digital electronics, we had talked about multiplexer circuits. Multiplexer circuit allowed us to choose what kind of input will be at the given output. Now this is exactly the opposite of this one. Now decoders are those combination devices. Let me mention you again, these are the combination circuits and combination devices which are used to actually deliver the particular information at particular output when there are number of inputs and number of outputs are available. When there are number of inputs and outputs are available, and if you need to decode it or you need to change the information, and suppose binary to octal, or you can say binary 3 to 8 line decoder, binary to hexadecimal, BCD to decimal, or BCD to 7 segment display. These kind of information needs to be represented and be changed by, decoded by the decoder circuits. As you can see, there are numbers of inputs. Here A0 to AN-1 are the number of inputs available to us. At the same time, Y0 to Ym-1 are the number of outputs available to us. Now these outputs can be a particular display where we can displaying the information. A particular input was there and we are displaying that particular information. Now this M, let me mention this, number of outputs should be less than equals to 2 to the power n. It cannot be greater than that. So this is the decoder circuit. Now suppose if there are 2 inputs available to us, so maximum output which is possible is the 4. The 4 output are possible. So this is how we can design whole circuits. Now decoder actually transform a particular information to a particular input line where numbers of output lines are available. So if we need to choose what inputs are needed to be transferred, that can be done by decoder circuit. Now the basic decoder, the first basic decoder in any kind of circuit can be a 2 to 4 line decoder. 2 to 4 line decoder will be the basic decoder where 2 denotes the number of inputs, 2 will be the inputs and 4 will be the outputs. 4 outputs will be available. Now these are the 4 output lines available to us where we need to send the information from this input side. So whenever we need to choose which information needs to be sent over there, we will use the circuit along with enable. Now this enable switch will allow us to choose whether to give these inputs to all the outputs or to a particular input needs to be chosen out. So that is how decoder circuit has been worked out. Now as you can see in this particular table, E, A, B, these are the 3 inputs available to us. E is enable and A and B are the inputs. Now Y0, Y1, Y2 and Y3 are the output lines available to us. Now whenever we are thinking about it, when enable is actually on the logical high side, let me come again, enable is on the logical high side irrespective of inputs. The output or the information will be transferred to all the output lines. When enable is high, the input will be transferred to all the output lines. But when enable is 0, we have this option. I beg your pardon. Whenever this enable is logical 0, we can have this option whether to choose this one, a particular line. Now in this, when both the E is 0 and A and B both are 0, what is the information is? The information Y0 is 0, otherwise all 3 inputs are high. So information has been transferred over there. Again the same thing happened So 0, there is no information of Y0, and all the information are provided to 3 parts, 3 output lines. Same with other one, when 001 is enabled, E is 0 and 01 is information. 01 is information. The output, second output will be logical ground 0. All others will have logical highs. So this is how you can construct the circuit. Now if you want to actually represent this particular circuit through NAND gates, it can be represented by this. We have this table. So what we can do is we can just construct the logical symbols and the proper by this truth table we can actually define the NAND gate and number of NAND gates which can be done for this one. Now where is the use of this decoder? Decoders are actually used in memory elements. In memory elements, memory devices, they have been frequently used. So we can use them as per our choices, where the information needs to be shared, where it needs to be shared, and how it needs to be shared. This is how we will done. We will talk about the logical representation of this through logic gates. Now how it can be done is, as we can see, enable is high, but A and B are on the different side. So by this we can actually choose. So suppose if you want to talk about this one, Y0, and if you are talking about the POS form, so it is quite simple. Other than this one, all are high in Y0. So we can derive the equation from this one. Again, we can do this for the sake of this one. Whenever it is 1 and irrespective of the elements, it is on the higher side. So enable is on the higher side. There will be output available to all the inputs. So enable will be there and others will vary as per your requirements. So we will talk about this. Well, just you need to see the truth table and the basic diagram of decoder first. Let me zoom into you so you can understand the circuit. Now this is how actually the decoder is working. As you can see, the M and N lines, 3 to 8 line decoder, and M should be less than equals to 2 to the power N, and in 2 to 4 line decoder, this particular logic table is quite visible right now because I am zooming in. So that is how this particular circuit has been worked out. Now this is the logical diagram of 2 to 4 line decoder. As you can see, there are 4 NAND gates are used. Now we will talk about the other important circuit in this scenario, and that is 3 to 8 line decoder. Now 3 to 8 line decoder are quite frequently used, and there is one more decoder which has been used, that is BCD to 7 segment display. So these are the very basic and very important decoders which needs to be understood and studied thoroughly. Now number of inputs available to us are 3 in 3 to 8 line decoders. So if number of inputs are A, B, C are number of inputs available to us, 3 inputs available, so there are technically 8 solutions out there, 8 inputs out there, 8 input combinations out there, right? Now how we are getting the output? 8 line output will be there. Now if we want to implement active high output, let me remind you, in logical reasoning and in this logic digital circuit, whenever we are saying active high and active low, the term active high means 1, logic 1, and active low means logic 0. So whenever we are talking these terms actually indicates that we have been using 1 or 0. In this particular example, we are using active high. So AND gate will be used for this purpose. AND gate will be used for this purpose, and Y0 is 1 and other outputs are considered as 0. So this is called active high. So in this circuit you can see when all the inputs are 0, the information will be transferred on to the first line, that is wire 0, and whenever a particular bit has been changed, like 001 is there, information will be transferred to the next line, and so on. It will be transferred like this. Come again. This is active high 3 to 8 line decoder circuit. So as you can see, Y0 equals to, right now whenever we are saying Y0 is active high, and that is 1. So whenever we are talking about the Y0, that is A bar, B bar, C bar, and Y7 is A, B, C. So that is how you can implement a simple circuit. So by using AND gates or NAND gates, you can actually convert this particular circuit or make this circuit, decoder circuit, quite useful. Now, is there a possibility then we can use this circuit for full subtractor? Yes, there is a possibility that 3 to 8 line decoder can be used as full adder, not subtractor, full adder. So this can be used for as a full adder circuit. So what is the possibility that we can use it? And if we want to implement a bigger decoder other than this one, then there is a possibility then we can do it. So we'll talk about this. First of all, what is the most important part in this is number of combinations are available, and active low and active high is the practical term which has been used quite frequently in examination. Whenever they are asking you about active low circuit, you need to draw that decoder circuit using NAND gate, and in that circuit, that particular output, let me remind you, the first output will be 0 if you are using active low, and others are 1. But in a different circuit, normal circuit, like we have drawn earlier, we are using AND gates, and the active high will be used. Now we will draw the next topic in this. It is quite easy. So I was talking about you that is there a possibility that full adder or subtractor can be used using 3 to 8 decoder. So full adder circuit by 3 to 8 line decoder. Is there a possibility? If in the exam this question has been asked, that is the reason I am telling you this thing. Yes, there is a possibility, then you can actually make full subtractor or full adder circuit using 3 to 8 line decoder. So how you are going to implement it? As you can see in this particular circuit, 3 to 8 line decoder. This is the 3 to 8 line decoder available to you. Now 3 inputs were available, that were A, B and C. Now 3 inputs were available and outputs are, that is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7 are available to you. Now Y0 are A bar, B bar, C bar. Y1 is A bar, B bar, C. Again A bar, B, C bar. A bar, B, C. A, B bar, C bar. A, B bar, C. And A, B, C bar, and the last one is ABC. This is the normal one. As you can see, these are outputs are available to you whenever you are using the active high circuit. Now this is the active high circuit. So if you want to implement the sum part of the in any circuit will be in full adder circuit, as you have already understood, the sum part in 1, 2, 4, 7 will be included. So 1, 2, 4, 7 will be included to get the sum, and if you want to access the carry, that is 3, 5, 6 and 7. 3, 5, 6 and 7 were used to get carry part. So if someone is asking you how you are going to implement it, so sum is sigma m, which parts were used? The 1, the first, the second, the fourth and 7. 1, 2, 4, 7, or y1 plus y2 plus y4 plus y7. That is your sum. What you need to do is you need to use AND gate for this circuit, sorry, OR gate, and for carry, for the carry part, what you need to use is, for carry, the equation will become sigma m 3, 5, 6, 7, y3 plus y5 plus y6 plus y7. For carry part, so in any examination, if they are going to ask you how to implement a full ladder circuit using 3 to 8 line decoder, this is your solution. What you need to draw is, you need to draw first 3 to 8 line decoder. Number of inputs are 3, number of outputs are 8, and what you need to do is, you need to choose a particular output to get the sum and carry, and just put the equation over there, and this is your solution. Let me zoom it to you so that you can understand this circuit. As you can see, that we can actually implement the full array circuit using 3 to 8 line decoder circuit. Now whether 4 to 16 decoder circuit can be implemented using 3 to 8 line decoders, yes, there is a possibility to it. What you can do is, this is another question in examination, 4 by 7 line decoder using 3 to 8 line decoder. Yes, it is possible. So how you are going to implement it? You are going to use now this enable in this particular circuit will be used let me draw it to you, then I will talk it out. Now you can see this. In this particular diagram, you can see that we use A, B, C, and the enable of this particular decoder has been used in inverted form, logical inverted form to other D3 to 8 line decoder. So this is how you are going to implement this particular circuit, and this actually output will actually enable this, and you will get 18 outputs out of this one, and this can be used. This is called 4 by 16 line decoder. You can actually implement this circuit where these four inputs, this one is the enable input for this one, and inverted enable input for this one. This has been used. So these are quite used in this line this way. So 3 were used like this, and other were used by like this, and you will get the output is the 16 line decoder, where number of inputs are 4 number of inputs were used in this particular circuit. So this is how you are going to use this particular equations or knowledge of this particular circuit. Now, as we have understood that full adder circuit can be used to get 3 line decoder, for full adder circuit. Full adder circuit can be get from 3 by 8 line decoder. So we can actually implement the full subtractor circuit too. So that can be done using the same formulas, but actually the result is quite different from this. But we need to understand that full subtractor is quite different from full adder. So the way we have been using this full adder analogy will be used in the full subtractor logical circuit. The next topic will be BCD to 7 segment display. How that 7 segment display has been made by this decoder circuit. It is quite interesting because in examinations they have been asking it continuously. Today we are done for the day, and take care, stay at home, and Bharat Mata ki Jai. See ya. Let me zoom it to you for the last part.